The Part 2 syllabus for the teaching license test presents a massive volume of information, covering everything from historical foundations to modern testing metrics. Passing this exam requires more than rote memorization. Success depends on recognizing how these individual topics fit into a broader pedagogical framework. We can organize the syllabus into 5 core pillars: methods of teaching, child development and education psychology, classroom management, assessment and evaluation, and school community and teacher. We begin with child development and education psychology. This pillar establishes the developmental stages and learning theories that provide a baseline for understanding the student. Viewing these pillars as an interconnected system provides a mental map. When you encounter a complex question, you can use this structure to classify the problem and eliminate irrelevant answer choices. A common challenge in the exam is distinguishing between different learning theories. Under time pressure, individual names and concepts often blur together. We can separate these schools of thought into a 4-quadrant matrix: behaviorism, cognitivism, constructivism, and social learning. Behaviorism focuses on observable stimulus and response. This quadrant is defined by Ivan Pavlov's conditioning and B.F. Skinner's reinforcement of behavior. Cognitivism, led by Jean Piaget, moves inside the mind. It examines internal processes like memory and developmental stages rather than just external behavior. This visualization represents the gap between what a learner can do alone and what they can do with help, Vygotsky's zone of proximal development. This is the core of constructivism, which, along with Bandura's social learning theory, emphasizes interaction and observation as key drivers of growth. By mapping a theorist to their specific quadrant, you can identify the primary mechanism of learning being tested. This prevents you from choosing a behavioral answer for a question focused on cognitive development. To see these theories in action, we will design a hypothetical STEM lesson on gravity. First, we use Bloom's taxonomy to define our learning objective. This ensures our instructional goals are measurable and aligned with the curriculum standards. Next, we choose Vygotsky's constructivism as our guide. We will use instructional scaffolding, providing temporary support that is gradually removed as the student gains independence. In a diverse classroom, we must apply Universal Design for Learning, or UDL. This framework ensures our lesson accommodates visual learners, students who struggle with procedures, and those ready for advanced challenges. We can map digital tools to these needs. For visual learners, we use PhET simulations as conceptual scaffolding. For students struggling with lab steps, we provide procedural scaffolding through checklists in a learning management system. For gifted learners, we use strategic scaffolding. Open-ended CAD tools let them apply gravity concepts to complex engineering designs, unrestricted by the baseline class pace. Pause the video for a moment. If a student understands the physics but struggles with the technical writing of the lab report, which type of scaffolding and which digital tool would you prioritize? You would prioritize procedural scaffolding using a digital template or word processing tool. This supports the writing process specifically, allowing the student to demonstrate their scientific knowledge without being blocked by the reporting format. This scaffolded lesson also activates the remaining pillars of the syllabus: assessment and classroom management. Using a quick digital poll through Google Forms provides formative assessment. This data immediately informs the teacher whether they need to adjust their methods for the next session. When teachers use this data to address misconceptions quickly, it reduces student frustration and supports a more structured, managed classroom environment. This flowchart connects the 5 pillars, the 4 quadrants of theory, and the specific types of digital scaffolding we've covered. It provides a single, unified view of the pedagogical content knowledge required for the test. Shifting from memorizing definitions to understanding how theory justifies your classroom decisions provides a logical way to evaluate exam scenarios. Use this framework to navigate the Part 2 syllabus.